Hello everyone. Number 83. Tailored expansion. Branches 1 about 82a if limit n close to infinite Rn equals 0 and fx is infinite times differentiable within I. Fx equals fa plus f dash a over 1 factorial times x minus a plus point plus f n a over n factorial times x minus a at n plus point. This is Taylor's expansion. Parenthesis 2, fx is infinite times differentiable in the interval I, and x is a real number, any value within I. And absolute fnx is smaller than m. And number m is irrelevant to n. Then limit n close to infinite Rn equals 0. And proof. Absolute Rn equals Rn fn a plus theta times x minus a over n factorial times x minus a at n, and absolute. And this is small or equal m times x minus a absolute x minus a at n over n factorial. This is condition. Then and now x fixed natural number m, take it big enough, but absolute x minus a small than m, and n great than m. Then this value equal absolute x minus a at n over n factorial equals n factorial as m minus 1 factorial times m plus 1 times point times n. This is n factorial. And molecule absolute x minus a times point x absolute x minus a to the n minus m plus 1 and times m minus 1 equal this is. And denominator m times m plus 1 times point times n. Now estimate m all n, then m, and this value, then this is great, m, okay, and this value small than this is. And absolute x minus a smaller than m now, and then x minus a divided m absolute is smaller than 1, okay, and n close to infinite, then this value close to 0. Example 1 over 2, n close to infinite, then this is close to 0. Then close to 0 and close to 0, and absolute Rn close to 0, then this is, I could say, this condition, then this is, and Taylor's expansion, okay. And parenthesis 3 summarize fx as infinite times differentiable, and absolute fnx as more than m, number m irrelevant to n in the interval I, then real number ax, any value within I, fx equal fa plus f dash a over 1 factorial times x minus a plus plus fna over n factorial times x minus a at n plus point. This is Taylor's expansion, okay. And parenthesis 4 at parenthesis 3 equal 0, then fx equal f0 plus f dash 0 over 1 factorial times x plus point plus fn 0 over n factorial times x at n plus point. This is Maclaurin's expansion. And example, fx equal e at x, I equal open section minus infinite to any n, and e at x, this function monotonous increase function. Then f and x equal e at x is small or equal e at n equal n. This is. And Maclaurin expansion e at x equal 1 plus x over 1 factorial plus plus x at n over n factorial plus point. And minus infinite small than x is small than infinite. Okay, it's finished.